We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello student, myself Professor Madhuri Parekh, Computer Engineering Department of AIT College. Today I will explain the topic parallel processor and Flynns taxonomy of computer organization architecture. Let's see what is a parallel processor. Here, to fulfill increasing demands for higher performance, it is necessary to process data concurrently to achieve better throughput. Processing data concurrently is known as a parallel processor. Parallel processor can do function using of multiple function unit or multiple processor. Multiple function unit, it means to execute 2 or more instructions at the same time. The system required 2 or more ALU. And multiple processor, it means system may have 2 or more processor operating concurrently. Let's see multiple function unit in this diagram. They provide a 2 or more arithmetic and logical unit. Each and every arithmetic logical unit can do the different kind of work. The first ALU do addition, subtraction, second do multiplication, third do logical unit, fourth one shift unit, fifth one increment, sixth one is floating addition, subtraction, floating point multiply, and floating point division. So here the example of the particular diagram is what? It is multiple function unit. It means it can execute 2 or more instruction at the same time. System may have 2 or more ALU. Multiple processors. System may have 2 or more processor operating concurrently. In this diagram, you can see there are the number of CPU, CPU1, CPU2, CPU3 and CPU4. All the CPU can do its own work at simultaneously. That is the example of multiple processor. So here the parallel processor have 2 type of architecture is available. The first is a multifunctional unit and second is a multiprocessor. Okay, understood student? Now let's we see the next topic, that is a Flynns taxonomy. Here, Flynns taxonomy is a classification of computing systems proposed by Michael Flynns. The basic idea of classification is that computer programs are composed of 2 streams, data stream and another is an instructional stream. Here, what is the meaning of instruction stream? It means normal instruction is fetch instruction from memory and execute in a processor. So the sequence of instruction is known as an instruction stream. Data stream, it means the operation performed on data in the processor, that is a data stream. This gives the possibility of 4 combinations depending on streams being serial or parallel. Here the Flynns taxonomy provide the 4 different kind of classification: SISD, SIMD, MISD and MIMD. Now let's see the Flynns taxonomy, that means single input, single output. Single input, multiple output. Multiple input, single output, and multiple input and multiple output. According to them, here it provides the 4 type of taxonomy. SISD is known as a single input stream and single data stream. Second one is single input stream and multiple data stream. Third one is a multiple input stream and single data stream. And fourth one is a multiple input stream and multiple data stream. Each and every have its own example. SISD have example is uniprocessor. SIMD have example is vector processor and parallel processing. MISD may be pipeline computers, MIMD multi-computers and multiprocessor. So now let's see one by one. Here single instruction stream, single data stream, it denoted by SISD. Here in this architecture, it executes one program on one set of data. This matches a program written using a procedural programming language and it's executed on single core CPU. फिगर शोज रिप्रेजेंटेशन ऑफ SISD आर्किटेक्चर. यहाँ पर स्टूडेंट इस आर्किटेक्चर में आपको बताया गया है कि देर आर only one input stream and one output stream. That means one instruction stream and one data stream, that is known as a single instruction stream and single data stream. Here the architecture, real architecture of SISD is that there is only one processor unit, there is only one control unit, and there is only one memory unit. That's why it is known as a single input stream and single data stream. Here only one particular part is available, so that's why the name is a single instruction stream and single data stream. Now we move on to the second, that is known as a single instruction stream and multiple data stream. In this architecture, one program is written, different copies of program run on different CPUs. In this architecture, synchronization must be achieved on the instruction level. In other words, at a certain moment, the same instruction should run on all processor and each processor execute this instruction on the particular data it has. Figure show a representation of SIMD. यहाँ पर स्टूडेंट आप देख सकते हो कि दो टाइप के डेटा स्ट्रीम है. One data stream is in a red color, another data stream in a yellow color. They have known as a different kind of CPU, CPU1 and CPU2. In both the CPU, same kind of instruction stream is executed and it provides the output. That's why it is known as a single instruction stream and multiple data stream. Now let's check the general architecture of SIMD. Here you can see in this diagram, there are processor unit 1, processor unit 2, processor unit N, which is collaborate with a memory module 1, memory module 2 and memory module N. This is known as a multiple data stream. But here the input string is what? Input string is a single. That's why it is known as a single instruction stream and multiple data stream. So this is the general architecture that you can remember. Now let's move on to the third one, that is a multiple instruction stream, single data stream, which is denoted by MISD. This is not a very common architecture, particularly hardware side. Algorithmically, this architecture is used when we want to apply and or test different algorithms on same data. For example, we want to apply different graphic filters to the same image. This figure show a representation of MISD architecture. यहाँ पर student आप देख रहे हो कि जो हमारा CPU है, that means data stream and another data stream, both have the similar kind of CPU. That's why it is known as a single data stream. And here it is multiple instruction stream. Both input stream are different. That different input string is done work with a single CPU. That means single data stream. So here this representation is give, that is a multiple instruction stream and single data stream. Now we can check it out, the general architecture. In this diagram, you can see that here it is number of control input 1, control input 2 and control input N, which is combined with the processor unit 1, processor unit 2 and processor unit N, which is collaborate with a number of multiple memory modules are there. Memory module 1, memory module 2 and memory module N. This particular architecture is known as a multiple instruction stream and single data stream. Okay, so now we can move on to the next Flynns taxonomy, that is fourth one, that is multiple instruction stream and multiple data stream, which is denoted by MIMD. This is the most general architecture. In this architecture, different instruction can run over different sets of data. Nowadays, all multi-core CPUs are considered MIMDs, as we can program them with a different instruction stream, ideally each running on a core on its own data. The figure shows the representation of MIMD. यहाँ पर स्टूडेंट आप देख सकते हो कि मल्टीपल इंस्ट्रक्शन स्ट्रीम, this one is a one kind of multiple string, and this is another instruction stream, so that is known as a multiple instruction stream. Both the stream have its own CPU, that is CPU1, CPU2. CPU1 is in a red color, CPU2 in a yellow color, that is known as a multiple data stream. So this architecture shows the MIMD. Now the general scenario of this MIMD is that there are number of control input 1, control input 2 and control input n, which is integrated with a processor unit 1, processor unit 2 and processor unit 2, which are combined with the data stream memory module 1, memory module 2 and memory module n. This architecture is denoted by MIMD. Okay students, so in this lecture you learn about what is a parallel processor and what is the Flynn taxonomy. So if you have any query, please give us a WhatsApp message or give me any kind of query on my Gmail account. Thank you student.